Hello everyone, InfoSec Pandey here. Welcome back to part 2 of the 100 SIEM and SOC interview question series. So in part 1, we have covered the fundamental, how the SIEM works, log management, detection rules, and real world threat detection like brute force attack, Kerberoasting, and C2 beaconing. But now we are going deeper, and in this part, we are tackling the advanced interview questions that companies ask when they want to know if you can actually think like a SOC analyst. So things like complex detection strategies, incident response scenarios, SIEM architecture decisions, and real investigation workflow. So if you want to move from knowing SIEM to actually working in a SOC, this is the part you don't want to miss. So in the part one, we have covered 45 questions, and now we can start from 46. So the question here is, your SIEM detect ransomware precursor activities on 3 endpoint. What do you do in the next 15 minutes? So time is very crucial for ransomwares. So we can start investigating the ransomware activities, and in the 0 to 2 minutes, we can confirm the alert. So basically, we are going to evaluate whether the alert is true positive or false positive. So for that, we can pull the EDR telemetry like process data, checking the shadow copy deletion activities on the systems like the BSS admin deleted shadows and some PowerShell WMIC activities, and also the rapid file modification related activities on the endpoints. And then we can confirm whether it's a true positive and false positive. Then from 2 to 5 minutes, we can escalate to IR lead immediately. So we can reach out to IR team by directly calling them or uh, messaging them, or we can visit on their desk directly and inform. So do not engage attacker or make any obvious move during this period. And then from 5 to 8 minutes, we can do the containment. So containment. So that's how we can stop the spreading this attack on other system as well. So we can disconnect the host from network. We can disable the user account. We can send the request to change the user's password. So that's how we have contained the attack. So this can be achieved through EDR. So we can directly log in on the EDR and isolate the machine, or if you are using SOAR playbooks, so you can isolate the host immediately from the alert and preserve the connection to your IR tooling. Then 8 to 12 minutes, we can scope the blast radius. We can use the SIEM query and check any other host with the same process has or connections or IOCs detected in the environment, and also any lateral movement from these three machines. And then next phase from 12 to 15 minutes, we can notify management per IR plan and then preserve disk images if possible. So that can help in the forensic activity. Forensic, the digital part, digital forensic. Do not reboot, because if you reboot, there are possibilities to lose your data for forensics. So do not reboot. And the pro tip here is speed is everything in ransomware response. So you can emphasize isolate before investigating. So this is how you can stop the spreading this attack. So this is stopping spread comes before understanding the how. And interviewer want to see you think about blast radius, not just about the three initial host. All right, the next question we have, how do you use SIEM for post incident forensics and timeline reconstructions? So SIEM is an incident historian. SIEM collect all the log and also cases, alerts, all your previous comments, screenshot, and user response. So SIEM is a historian server. So the steps we can follow, we can define the time frame, and based on the initial IOCs, we can work backward to find the patient zero, and then build the timeline. So based on the queries across all the log sources, sorted by timestamp, like authentication activities, all the process created on the affected devices or in the environment, and the network activities, file access. And then third step we can follow, identify pivots. So we can check where did attacker move from or to. We can use the authentication log to trace lateral movement, and then we can find the persistent. So all the scheduled tasks created using 4698 on Windows and cron job on Linux, and new services created 7045 registry modifications. So this help understanding the persistent mechanism. Then identify data accessed. So we can check the file share access log, share point audit log, DLP events, and we can reconstruct the timeline. Then export evidences. So once you have all these package complete, you can preserve raw log in code admissible format like chain of custody without tampering the data, and then document the findings. So in the incident report with citations to log events. So sometime you need to present your data in a code, and that's why the digital forensic is very important without tampering the log. Being able to reconstruct an attack timeline from SIEM data is one of the most in demand skill in IR. So if you're working as L2 or L3, your next career path can be DFIR, where you play with some tool like data acquisition tool, and also SIEM part, where you can pull the data using queries and create a complete package. So practice building timeline in Splunk or Elastic. It's a hands-on skill that hard to fake in an interview. All right, next question. What does containment mean in an incident, and how does SIEM support it? So a containment that is stop the bleeding. It prevents the attacker from spreading from further or causing more damage while you investigate and remediate. So basically, this stop the blast radius and also contain the threat. So there are types. So short-term containment, like isolating the affected systems, blocking IOCs like IPs, domains, URLs on firewall side or proxy side, and disable the compromised account. So this is the short-term action you can take. Number two, we have long-term containment. So long-term containment, like patching the exploited vulnerability, rebuild the compromised system. So SIEM supports containment by identifying the full scope of the compromised system. So this is like a getting forensic package, and also finding the lateral movement tracking, providing the IOCs list to block, like IP address, hashes, domain. So you can collect all the IOCs using hunting or querying the available data on the compromised machine, and monitoring post containment for reinfection or attacker pivot to a new system. So SIEM can help getting the forensic package and IOCs, and also monitoring reinfection. So the pro tip is never jump straight to eradication. Contain first, stop the spread, stop the bleeding, then eradicate. I mean the cleanup. So skipping containment equal to attacker pivot to uncleaned systems before you finish. So this is a classic mistake often candidate make in the interview. So first contain, then eradicate. All right. How do you handle a false positive investigation without wasting analyst time? So we can do the quick triage. So you can apply the 2 minute rule. 2 minute rule. So what is 2 minute rule? So if it is obviously false positive in under 2 minutes, close it with documentation. So you can see if any previous alert, tie up previous alert, and also you can check if it is a known activity. or you can see it's a duplicate. So this is a 2-minute rule you can follow and you can make the decision. And the documentation, why? So if it is a false positive, don't just close it, note the reason. So if you make the note and put it in the case, like if it is a known scanner or expected behavior from the user, or it is a whitelisted service, so this will help next time when somebody get the same alert, they can immediately close it. And also tune the rule. So if the same false positive reoccurs, that's the tuning ticket, not just a close. So you can provide the feedback to the detection engineering team and they can tune it. Track false positive rate per rule. So a rule producing 95% false positive need rebuilding, not just repeated closing. So this is a thumb rule you can follow. Reconstruct. Okay, you can also use the automation like SOAR can auto triage the common false positive patterns using the enrichment, like is source IP is a known internal scanner or any known activity from the user, so auto close it. So this is where the SOAR can help. And the pro tip is the worst thing you can do is close false positive without learning from them. So this is not recommended. You always document why you have closed the case as a false positive and also provide the feedback to detection engineering team. So every false positive is a tuning opportunity. So track false positive reasons in your ticketing system and pattern the emerge that drive systematic improvement. So this is how you can mature your SOC and improve your SOC. What is the tabletop exercise and how does a SIEM factor into it? So basically, a tabletop exercise is a simulated incident discussion or simulated incident response that leadership and SOC walk through a scenario. So suppose a ransomware hit to your headquarters and talk through their responses. So this is a simulated activity where everybody come on the table and discuss about the possibilities, scenario, and the mindset of the SOC analyst and team, how they can handle the actual incident or actual ransomware activity. So, what is the SIEM role in the tabletop exercise? So, the pre exercise like identify what SIEM cannot detect in this scenario, like the coverage gap. So, find the gap. Number two, during the exercise, so you can use the real SIEM queries to find synthetic injection data like purple teaming exercises and activities. So, you can build the SOPs, queries for actual attack. And so the post exercise like documenting what we found, what we missed, what is gap identified. So create tuning onboarding backlogs. And the real value here is a tabletop often reveal that no one knows who to call. SIEM doesn't have the right log sources or playbook are outdated. So these are the critical finding before the real breach. So that's why the tabletop exercise are very important. And the pro tip here is monitoring purple teaming exercise. So it's a combination of red teaming and blue teaming, where the attacker simulate one attack on a test machine, and then blue team monitor it on other hand and stop the attack. So like red team attack and blue team detect. So purple teaming equal to both together reviewing the gap. And alongside tabletop shows you understand the full spectrum of detection validation. All right, 51. What is the difference between an IOC and TTP? So an IOC is indicator of compromise. So it is an artifact of a specific attack like IP address of the attacker, malware has, domain name. or URLs or email detail of the sender. So these are the IOCs. So this is useful, but if a mirror, because attackers always rotate the IPs and the change domains like fingerprint at a cybercrime, but the TTP is something like a tactic, technique, and procedure. So it's a attacker's method, and this is how they move laterally. They carry their attack, the brute force, the lateral movement, and this is how they establish persistence and how they exfiltrate. So the TTP basically explain their behavior, and TTP are much more stable across campaign. The same APT uses the same technique for years. So detecting TTPs via behavioral rule is more durable than blocking IOCs, so which get you stale in days. This concept mapped directly to pyramid of pain created by David Bianso. So if you don't know what is pyramid of pain, I can tell you. But if you want a detailed video of pyramid of pain, you can just let me know. I can create a separate video of it. So this is the attacker's TTP, and then the tools they carry, and then networking artifacts, and the host artifact, and then domain name, and IP address, and then hash value. Last one is hash value. So the TTP is very tough to change. This is more pain for them if they change it. And the tools also challenging, because developing the tool or purchasing the tool is a challenge. And then networking and host artifact, so if they change it regularly, it's annoying. And then the domain name, so domain name changing is very simple. They can purchase a new domain and launch the attack. And then IP address, so IP address is very easy to change. They can use the VPN or something, and it can be changed. And the hash value is like uh, tribal. So basically, this is a must know model for detection engineers. IOCs are at the bottom, so you can see here we have the IOCs. So this is easy for attacker to change, and these are the least pain for them, so they can frequently change it. But the TTPs at the top, you can see here, it is hardest to change and it is most painful for them. So always push your detection strategies towards the top of the pyramid. So if you're creating detection rule, always focus here, not here, because IOCs are less painful. So if you block the IOCs, they can create another, and you will get stale in days. All right. How do you handle an incident and where you suspect log tampering or SIEM evasion? So a log tampering is when an attacker delete, modify, or disrupt your logging to hide track. So they can disable forwarder, or disable the AB, so they can hide their attack and tools that they are running. And the detection signals are like event code 1102. So if you're using Windows machine 1102, so this is a audit log, uh, which triggers when attackers or anybody clear the audit log. So this is a Windows security event for log clearing. And the ingestion gap, so alert if a source stops sending log to more than 5 to 15 minutes, especially critical sources like DC. So you can alert if your data source is down, data source is down. And then timestamp anomalies, so events with missing time ranges or inconsistent sequences. So if you are running a query, suppose you are running a SPL query that return a complete chart here, and these are the data ingested. And if you see there are some blank towers like this, so that means this is the gap of log, and you need to identify why you have gap for these logs and why the logs are not ingested during this period. And the log forwarding disruptions, so like agent stopped, service killed, 7036, like service control manager events. So these are the sign. If you see on your system, this could be a log tampering or SIEM evasion technique. And the response, so immediately you can escalate the log cleared in a strong breach indicator. So the response here is you can immediately escalate it to IR team and investigate log cleared on which systems and when it got cleared and what other activities performed on the system. So this is a strong breach indicator. And also you can check the upstream sources. Use immutable logging like Syslog to see that source cannot write to. The immutable login is the best defense, like send log to a destination. The source system cannot modify or delete it from. Like your cloud based SIEM like Sentinel, Chronicle, Splunk with ingestion label, write once storage are ideal for this. 53. What information do you capture in an incident report? So the key sections that we document in the report, the incident report, the executive summary. So executive summary is a summary that contains what happened, what was the impact, what is the status of the incident. Then number two, timeline. So a detailed chronology of the event with log citations, and then root cause. So how did the attacker get in? And then scope. So what systems, data, user affected, and then if any IOCs like IP address, file has domain URL for blocking, and then action taken. So containment, eradication, recovery step is part of action taken, and then evidence. So evidence is like log that exported and the screenshot, and then lesson learned. So lesson learned have the detection gaps, response gaps, and the recommendation. So lesson learned, if any gap identified or if we have any improvement plan, so that can be a part of lesson learned. Then recommendations, so any specific actionable recommendation that can be prioritized using lesson learned. So these all are the part of incident report. So if we are creating an incident report, we should include all these information. A good incident report is written for two audience. One is for the technical audience, like the detailed timeline, evidence, RCA, lesson learned, everything, and executive, like non technical persons, but the executive level, so they can understand the impact, business risk, cost, etc. So you can communicate at both level. 54. What is dwell time and how do you reduce it using your SIEM? So suppose there is an attacker who active in the environment from last 6 months, from last 6 months, and today we received an alert that we have some suspicious activity going on in the environment. So this is the dwell time. So basically a dwell time is the number of days an attacker operate in your environment before detection. So the average is still 10 to 24 days in 2024. So it varies by various sources, and the long dwell time equal to more damage. So this is the classic example we have. So the attacker is active from last 6 months. And reducing dwell time with SIEM. So what actions we can take so we can improve the detection rule or coverage. So the more rule we have, the more we can cover, right? So covering initial access and lateral movement. So as previously I told, we can have the full visibility of the MITRE coverage in our environment, and if any gap identified, so we can create more rule. And then threat hunt proactively. So we should not wait for the alerts. We should go beyond and hunt the attackers. And then enable UEBA. So UEBA is a machine learning model that can catch the slow attacker behavior that regular rule miss, and then reduce the alert fatigue. So when analyst can focus on quality alert, nothing get missed, right? And then automated enrichment. So we can enrich all the IOCs and threat intelligence details in the alert itself. So the faster triage and faster escalation and then shorter dwell. So the goal is to reduce the dwell time. And the pro tip is citing that average dwell time has decreased from 200 days in 2015 to 10 to 16 days in 2024. So you can thank to better tooling, so you follow the industry trend. So interviewers appreciate the current context. How do you escalate a security incident? What triggers escalations? So escalation triggers number one, severity. So you can mention whether it's a confirmed incident or it's a suspected incident. Then we have a scoping. So more than n systems affected, whether one system affected or two system affected or five system affected. And then data type, what data has been accessed, whether it's a PII data or financial data or IP accessed. And number four, we have persistence confirmed. So an attacker has a foothold, not just a probe. And then number five, we have known APT indicator. So we can also escalate if there is a nation state or ransomware group TTP detected. Then number six, the business critical systems affected. So the process is we can use L1 triage, then L2 confirm the incident, then L3 and IR lead can engage for confirmed incident, and then management notified per escalation matrix, and then there is a legal compliance involved if the data breach happened, and then external IR firm if scope exceeded internal capabilities. So always document escalation path and timestamp. So let's create a escalation path here. So an ideal escalation path looks like this. Escalation path. So it will start from L1, then L2, then IR or L3 lead, and then management like your CISO, and then it will go to the legal compliance, and then some third party forensics. Pro tip is having a clear escalation matrix is a sign of SOC maturity. So who get called in what order for what incident type. So mentioning that you would ensure the matrix is tested annually shows you think beyond tools. All right, what is Syslog and what are the key limitation for SIEM integration? So a Syslog is the standard log transport protocol. So Syslog is a protocol for Unix and Linux system and for some networking devices as well. So syslog is a standard log transport protocol for Unix, Linux, and networking devices like RFC 5424, and it is uses UDP 514 protocol or port number, or TCP 514 for reliable delivery, or TCP 6514 for TLS. So the format includes priority like facility plus severity, timestamp, host name, process, message, and the limitations are UDP is unreliable. So the messages can be dropped under load with no acknowledgement, and no native encryption available in the syslog. So this is another disadvantage or limitation. So UDP syslog is plain text, and the timestamp inconsistencies. So the clock drift if the NTP not configured, and then parsing fragility. So It is free form message field require custom parser per device type. No buffering. So if SIM is down, message are lost. So the pro tip is, so knowing the difference between UDP versus TCP syslog and syslog versus syslog NG versus R syslog is very practical knowledge. And TCP syslog with TLS is the right answer for the secure environment. So what is Windows Event Forwarding, the WEF, and how it is used for SIEM collection? So a WEF, Window Event Forwarding, is a native Windows mechanism to forward event from endpoint to a central window event collector machine or server without installing agent. So we can create a WEC server here, which is Windows Event Collector server. And suppose if we have 1000 Windows machine, we can forward the log to the WEC server using policy based configuration on GPO side. So all the log will be collected to a WEC server. So this uses the WS management protocol. So we can use it WS management protocol and configured via GPO, the push subscription or pull subscription model. And the benefit is it's agent free. So we can manage 1000 machine without deploying any agent on these machine. So only we can use the GPO and policy based subscription to forward the log, and it's a native mechanism and it is most reliable because it's HTTP based acknowledgement and also can filter events before forwarding. So there is an option where you can use the XML based file and filter or include exclude the event IDs. So WC then forward the log to the SIEM via Syslog or Splunk forwarder. So here either you can deploy an agent or use the syslog method to send the log to SIEM system. So this is for great environments where the restrictions on the third party agent deployment. So if your organization have some uh, compliance requirement to not deploy any third party agent, or some network connectivity issue is there, or network is not enabled on those servers, so you can use this method. And the pro tip is WEF plus NXLog on the WEC server is a common enterprise architecture for agentless window log collection. So knowing this trick or stack shows real world deployment experience. 58. What is a log parser and how do you troubleshoot a broken one? So a log parser extract the structured field from raw log or raw log text, and for a long line like this is a timestamp and time, then host detail, then protocol, and then failed password for the root from IP address. So here a parser is going to extract the timestamp, host name, process, source IP, user, action, and the troubleshooting steps are: check raw events in SIEM. So is the raw log arriving correctly or it is truncate or broken? Then also you can check whether the test regex against the sample log. So you can write your uh, regex and check whether it is parsing the log correctly or not. And then you can use the online regex texter where you can paste one sample or multiple sample, and you can write your regex and test it. Number third, check for the log formatting changes. So vendor update often break the parsers, so you need to update it again. And then look for the multi-line events that the parser is not grouping. So if you have various type of log coming in a single data source, you can write multiple regex or parser for that. And then verify field extraction in a test mode before pushing to the production. Pro tip is log format changes after vendor update silently, so it also break the parser and corrupt your detection data. So you can set up the field completeness monitoring and alert if key field like source IP, user action start showing null values. So, what is log enrichment and what data source are commonly used for it? So, a log enrichment add context to raw log events before storage. So, the common enrichment sources are like geo IP. So, it map the IP to the country, city. So, you can use the MaxMind geolite to map all your data, and the threat intel piece. So, you can check IP domain has against IOC speed, and number third is asset database or CMDB database. So if you have a CMDB database in your service now, you can map the host name, IP, honor of the host, criticality of the host, and environment, whether it's a prod environment or dev environment. So all those information you can map. And then number four, identify HR data. So you can map the username to the department, manager, employee status as well. And number five, the vulnerability data. So you can tag the asset with known CVs from Tenable, Nessus, Qualys, and also cloud metadata. So also you can map the cloud instance ID to teams and projects. And the enrichment at ingest time is best. So make search and correlation faster and more contextual. So that's why the log enrichment is very important from security perspective. And the pro tip is enrichment is what separate a raw log repository from an intelligent SIEM. So an alert that already shows the source IP belong to a terminated employee's last known host IP, then this is going to save 10 minutes per triage time per alert. So this is a big win for MTTR. All right, question number 60. How do you handle time synchronization issue in SIEM log management? So the time synchronization issue cause events to appear out of order, and also the correlation rules to miss multi-source pattern, and forensic timeline to be inaccurate. So the solutions are NTP everywhere. So NTP server, the network time protocol, NTP network time protocol server should be deployed everywhere. So all the log sources must sync to a reliable NTP server. So SIEM should use the index time versus event time. Index time versus event time. So event time is when the event happened from the log. So this is the actual time, and the index time is when the SIM receive it. So SIM receive it. So you can use event time filter for correlation, but track index time for ingestion latency monitoring. So you can also alert on large discrepancies between index time and event time. So this is a potential clock drift or delayed log forwarding. And the pro tip, a classic interview catch question: what is the difference between event time and index time in Splunk? So most candidates know one but not both, and knowing both and when to use each is very impressive in the interview. All right, what is log compression and what ratio can be realistically expect? So a log compression reduce the storage cost significantly. So it compress the log. So suppose there is 100 GB data, it can compress it to 50 GB or 70 GB. So raw logs are highly repetitive, like repeated field name, timestamp, host name, etc. And this is ideal for compression. So we can compress the duplicate data or logs. And the realistic ratios are like text log, like your syslog log or Windows event log. So the ratio we can use 5 ratio 1 to 5, 10 ratio 1. So the comparison with GZIP and GZIP std. And the JSON log, so JSON log ratio is 3 ratio 5 to 5 ratio 1. And the binary already compressed, so it is minimal. 100 GB of data per day raw log might store at 15 to 20 GB per day compressed. So cloud SIEM handle this automatically, but the on-prem you need to configure the compression at the storage tier. And note, so compressed log slightly increase your query time and balance based on your hot storage query requirement. So the compression is very important, but you need to choose it wisely. And the pro tip, so mentioning JD standard JSTD is a modern alternate of gzip for log compression, shows you are current. It is faster with better compression ratios and increasingly used in Elasticsearch and Splunk. 62. How do you ensure log integrity and detect tampered or forged logs? So, ensuring integrity, we can use cryptographic hashing. So, the hash each log batch file at the collection time and re-verify it during forensics. And then number two, the immutable write once storage. So the warm storage or cloud up and only buckets like the S3 object lock. So this help ensuring the integrity. Then digital signing. So some logs shippers support signing log stream. So this can help ensuring the integrity. And then the SIEM ingestion monitoring. So alerts on the gap in expected log flow, like source stopped sending. So this is a sign of the possible tampering or outage. And then the central syslog server, we can forward the log to a destination the source cannot access to delete. So suppose we have 1000 system here, and then we have a syslog server here. We can transfer all the data to a syslog server, and this server should not have access to this, and then we can transfer it to SIEM server. And then event code 1102 monitoring, so Windows security event for log clearing. So you can set up alert for 1102. So this is audit log. Pro tip, in regulated environment like PCI DSS, FedRAMP, HIPAA, log integrity is an audit requirement. So knowing specific control like warm, crypto hashing, central syslog signals, you understand compliance requirement, not just technical ones. 63. What is a common event format, the CEF, and when is it used? So, a common event format, the CEF, is a log format standard created by ArcSight HP. So, this is a standard log format created by ArcSight, and the structure looks like this. So, CF have version detail, device vendor detail, device product detail, device version detail, signature ID, name, severity, and then extension. So this is widely supported by security vendors like Palo Alto, Cisco, McAfee. All these vendors support CEF output, and this makes the parsing easier because the field positions are standard, so they are divided by some separators. And when we can use it, so when we have the many network and security devices support CF as the output format for syslog. So if you are integrating a new device and it supports CF, choose it over custom syslog, so it will parse cleanly with minimal custom work. So if your networking device supports CF, go for it. Pro tip is also know leaf the log event extended format. So this is created by IBM's competing standard used in QRadar, and the OCSF, the Open Cybersecurity Schema Framework. So the new open standard being adopted by AWS, Splunk, and other in 2023. So the key log format you need to know: leaf, CEF, and then OCF. And also you can create your custom log formats. All right. How do you optimize SIEM performance when ingestion volume spike unexpectedly? So the strategies we can follow: number one, identify the spike source. So why and how the spike happened. So which log source is flooding, then query ingestion volume by source. So we can have some query by source type, and we can visualize it in bar chart and understand which source is generating or contributing to the spike. Then number two, we have the filter at the edge. So that means you can add filters on the forwarder side or aggregator side to drop noise. So suppose you are using Cribble, you can allow only the required uh, data and filter out the junks. So like debugging log, repeated health checks and all we can drop. So these are the noise. And then sampling. So sampling for non-security critical high volume sources. So you can sample at 10 to 20% like DNS proxy for non-threat intel matched traffic. And then scaling. So scaling indexers and node. So if cloud scale out ingestion capacity temporarily, so that will help you to understand and have the RCA, the root cause analysis for the spike. And then throttle or queue, so configure the forwarder queuing to prevent overwhelming the indexers. And then also alert on the greater than 2x normal ingestion volume. So if any spike happen, this can indicate an attack like ransomware generating or DDoS flooding or a misconfigured source. So you should always alert for unexpected spikes on data source. So pro tip is a sudden spike in a Windows event ID 4688 from one host could be a ransomware encrypting file and creating new process. So don't just filter unexpected spike, investigate them first. What is Splunk heavy forwarder versus universal forwarder, and when do you use each? So a universal forwarder is very lightweight, minimal footprint, forward raw data to minimal processing. So this is your Splunk. And universal forwarder is an agent that you can deploy on each device and send directly to Splunk, the raw data. So this is best for most endpoint and servers, and it cannot do significant parsing. But the heavy forwarder, so the HF, so the heavy forwarder is like a full Splunk instance configured for data routing, processing. It can do parsing, filtering, all the routing, and also anonymize and transform data before sending. So we can use the heavy forwarder when you need to receive Syslog, TCP from network devices. So universal forwarder cannot receive. You need to do significant field extraction before indexing, and you need to route the multiple destinations. So uh, or you are acting as a collection aggregator for network segment. So heavy forwarder is more advanced, which can collect all the data parsing and then routing. But the universal forwarder is very lightweight agent that can catch the data from the endpoint and dispatch. So this is catch, dispatch, but this also parse the data, filter the data, receive the data, and route the data. So pro tip is the heavy forwarder is often confused with the universal forwarder, but the key differentiator are universal forwarder send while heavy forwarder receive and transform the data. So in a typical architecture, endpoint send data to universal forwarder and then universal forwarder to heavy forwarder for aggregation routing and then indexer. All right, what SIEM use cases would you build significantly for cloud environment like AWS and Azure? So the top cloud SIEM use cases you can create: number one, impossible travel and the risky sign in. So this is for the anomalous authentication pattern in intra ID or AWS IAM. And the number two, root admin account use. So root user are very powerful user in cloud environment, and AWS root account should never be used. So you can alert on any CloudTrail root event. And then security group, network security group changes. So this is a permissive rule added like 0.0.0.0, and this is a inbound. So this is a inbound, that mean your server is exposed to internet. And then secret manager access, so like the sensitive credential accessed by unusual identities, and that immediately we need to alert. Number 5, S3 bucket policy changes. So we should alert if any bucket made public. Privilege escalation via IAM. So new admin policies attached, role assumed. So we need to immediately trigger an alert for it. Then crypto mining detection. So these are the very dangerous attacks and unusual GPUs instance created in the cloud region and started mining the data. So this should also immediately alerted. CloudTrail disabled. So alert on the CloudTrail being turned off. So this is another sign of tampering and hiding the attack. So this should also alert immediately. Pro tip is AWS root account uses is a easiest cloud detection rule to write and the highest fidelity you can get. So it is almost always suspicious. So make it your first AWS use case. All right. How do you build a use case to detect phishing related compromise in Office 365 or M365? So the log sources we can use like Azure AD, sign in logs, M365, unified audit log, and also Defender for M365, Defender log, and all the alerts. So the detection logic we can create, number one, suspicious OAuth app consent. So when user grants permission to a unknown app or register a new app, requesting email dot read, calendar dot read. So this should immediately notify it to the security team. And then email forwarding rule created. So if any inbox rule forwarded all the email to external address, so this is a real sign of attack. And then mass email read. So if any account read the 1,000 plus email in 30 minutes, so it's a business email compromise reconnaissance. And then suspicious file downloaded from the share point. So this is a post login anomaly where the attacker get the access to the account and started downloading tons of file from SharePoint. And then failed MFA followed by success from the same IP. So this is a MFA fatigue push, and correlate these events with Defender for Office 365 phishing detection events. Pro tip, MFA fatigue attack. So like sending push notification until user accidentally accept are the top initial access method in 2026, and having a SIEM rule for MFA push denied greater than 5 times, then accept is a highly relevant. What would a golden ticket attack detection use case look like in SIEM? So a golden ticket forge Kerberoast TGTs using the stolen KRB TGT has, and this giving attacker domain admin access. So this is very simple but dangerous. So the detection challenges are like forged ticket look legitimate, and the signal that we can utilize, number one, the event code. So 4769 with unusual ticket lifetime, like default maximum is 10 hour, but the forged ticket can be set to year. So this is a sign of an attack, the Kerberos attack. And you can check the TGT lifetime is more than 10 hours. So this is one signal that we can use. And the second one is 4624. So we can correlate 4769 with 4624, the logon events where the ticket encryption type doesn't match to DC setting, and then ticket from account that has been disabled. So you can also check the attacker can use the old account SIDs in the forged ticket. And number 4, DCCs TGS request without a corresponding to TGT exchange. So this is a forged ticket bypass normal TGT instance, and this combined with monitoring for ARBTGT password change events. And the pro tip is golden ticket detection is hard and require Kerberos label logging that most organizations don't have enabled. So this is good catch and it is very important. And mentioning this detection gap and how to address is enable Kerberos logging, use MD, Microsoft Defender for identity, the MDI shows depth knowledge. All right, how do you build a use case for detecting DNS tunneling? So a DNS tunneling uses DNS queries to exfiltrate data or establish command and control server. So like the encoded data in subdomain labels. So the detection signal we can use in SIEM via DNS logs, like number one, the high query volume from one host to one domain. So suppose there is a one host and it is start sending request to a single domain, and then long subdomain labels, like the normal domains are less than 20 characters, but the tunneling have 50 characters. So long domain, high query, and then high entropy in subdomain like base 64 hex encoded data look random. So encoded data and the unusual record type like txt null cname queries in high volume, unusual record, and then consistent interval querying. So this is a sign of weakening via DNS. And then number six, new uncommon domains like the DGA, the domain generated using algorithm or newly registered domain. And this is state average subdomain length per source and alert on deviations. So pro tip is JEEK, the formerly BRO, is excellent for DNS anomaly detection. So if your organization uses JEEK, mentioning that you would leverage its DNS log, the DNS.log for tunneling detection shows network security maturity. Question number 70. Build a use case to detect a service account being used interactively. So this is a potential compromise. So service account. So what is service account? So service account is a special account, or we can say a non-human account used by applications, apps, virtual machines, or services to authenticate and interact with APIs, database, and some other services automatically. So unlike user account, service accounts are like human login credential, like they do not use the password or MFA. They're using API keys. So no password, they use API keys or tokens instead of allowing secure and automatic machine to machine interaction. So service accounts should never log in interactively using logon type 2 or local consoles or via RDP, because they are not the human account, right? With logon type 10. So how you can detect it, the compromise? So you can use the event code 4624 and logon type 2 to 10 and account in service account list. So if you have a list of your service account, you can put your service account here and then you can complete the detection query. So the enrichment part, so you can pull the details from the AD, the OU, and the naming convention for the service account like SBC underscore, SA underscore, or SBC hyphen, and build a dynamic lookup. So if you have the list, you can detect related uh, anomalies or compromise related to service account, and you can alert with high severity when service account got compromised. This is a privilege escalation risk. So since they have very powerful permission. So service account have very powerful permission. They can manage app, VMs, services to authenticate, API, database, etc. Right? So they have a very powerful permissions. And how you can tune it? So you can exclude the automated uh, testing environment where the service account may be used for integration or some testing part. So this is how you can tune it. And the scenario, so service account sbc hyphen backup login interactively to a workstation at 11 p.m. How you will deal it? So there are two possibilities: either someone knows the password and is using it for their session, or malware impersonating. So these are the two possible scenarios, and both are the incidents. So we need to deal it. We need to disable the service account, remove the sessions, and isolate the machine or app. Then service account with interactive logon right plus no MFA plus high privilege are the major attack surface. So you can do a quick assessment or auditing in your environment, and if you found these three uh, attack vectors or attack surface, you need to work on it and reduce it. So mentioning the need of restrict logon right in AD, like denying interactive logon, GPO shows you think prevention plus detection mindset. 71. How would you detect a ransomware attack before files are encrypted? So pre-encryption ransomware signals in SIEM are: number one, shadow copy deletion. So if you see the VSS admin deleted the shadows, or WMIC shadow copy delete commands in process command line using event code 4688, which is for new process creation or new service creation. And then number two, the backup disruption. So if you see the services stopped, like VSS service, window backup service, and connection to backup server also is a sign of pre-encryption ransomware activities. Then lateral movement. So if you see SMB connections to many host, PSEXCs uses, and then also admin share access using C dollar or admin dollar commands. So this is another sign. Then number four, the privilege escalation. So if you see the system label process creation from user context, so this is another sign. Then mass file staging, so reading large number of file rapidly. So your DLP or file access log can give you these context. And suspicious persistence, so if you see scheduled task or registry run key created in the environment or the machine, so this is another pre-encryption ransomware signals. So catching two or more of these in correlation equal to ransomware precursor alert. Pro tip is like building a ransomware precursor correlation rule, which is going to combine the VSS deletion, lateral movement, backup disruption, is a powerful high signal use case, and no single indicator is reliable. So the combination can help you to detect the uh, pre-encryption ransomware activities and reduce the false positives. 72. How would you detect an insider threat using SIEM? So insider threat are harder than external because the user is already authorized, they have all the access which they need. So normal activity looks similar to malicious. And the detection signals are: number one, off hour activities or access to sensitive system by user with no business justification. So suppose you have a help desk employee who started accessing the financial system, or started accessing the SAP database, then mass data access. So if user is downloading or copying far more data than their role required, so this is another red flag. And then access to systems data outside their role. So suppose a finance analyst accessing the HR system. Number four, resigned terminated employees activity. So the resigned employee or terminated employee accessing after notice given, and especially the sensitive data, PII data or SAP database related to customer record. Then number five, the USB or removable media. So if the user write on with elevated data access the same day, so this is another sign. And then the DLP plus SIEM correlation. So DLP works by labels. So like in your organization you have a lot of documents, so you can put a label of it, and if somebody try to open it or transfer it, then DLP can catch it by reading the labels. So DLP catches sensitive data transfers using label reading, and SIEM add authentication and access context, so you can get the full picture what is happening in the environment. And the UEBA is especially effective here because UEBA create a baseline, what is user's role, which department they're working, and what is their baseline, like normal login hours and all. So UEBA is going to create a baseline for each user's normal behavior. And then pro tip, insider threat program require HR and legal involvement, because you cannot just surveil employees without policy and legal framework, right? So if you see someone transferring the data from your environment or uh, from your sensitive database to their personal email, you can directly reach out to the legal and HR, then you can take the actions. So mentioning this shows you understand the organizational, not just technical dimensions. 73. What use case would you build to detect a compromised VPN account? So the key signals are in VPN and remote access log, like number one, impossible travel activity. So suppose a user everyday login from USA, but after 2 minutes he logged in from Australia. So VPN logins from geographically impossible location within a short time window. So this is an impossible travel activity. Then first time country reason login. So if user is always logging from USA and started logging from Pakistan, then this is another red flag. So like user always connect from US and suddenly from Romania or Pakistan. Then number three, multiple concurrent sessions. So the same account logged in into VPN from two IP simultaneously. So suppose user is logging from 10.2.3.10, but also logged in using 198.168.1.2. Then off hour access pattern change. So if user always log in from 9 to 5 but suddenly started logging at 3 a.m., so this is the red flag. Then failed MFA before success. So MFA fatigue or stolen one time code. So if you see 5 MFA failure and 1 MFA success in short time period, like in 30 minutes, then it is another red flag. So enrich VPN events with users normal login pattern and geo baseline from Azure AD, which is also known as Intra ID or Okta sign in log history. And the pro tip is VPN is a classic initial access vector, because when if you are working as a like organizational employee, you know, if you log in on your system, you need to first log in on the VPN, right? So VPN is the first initial access vector and one of the highest value log source for detection. So if an organization asks what you would onboard first post breach, VPN log plus identity logs are always the answer. How would you build a SIEM use case for detecting supply chain compromise? So supply chain attack, like we know SolarWind 3CX are hard because the malicious code is in the trusted software. So suppose this is your trusted software which you are using from long time, or it is a known vendor. So suddenly the attacker compromise their supply chain and distribute it to multiple clients using update or using patch. So the detection approach are: number one, network connection from trusted software to unusual IP domains. So if you see your trusted software is connecting with unusual IP or domain, this is a red flag. So like SolarWind should not beacon to random Azure IP, right? And then number two, unusual process children. So trusted update process spawning PowerShell or CMD, which earlier they were not doing, but recently they started the PowerShell and CMD. So this is another red flag. Number three, unexpected outbound On new port from known good applications is another sign. Number 4, binary hash monitoring. So we can alert if the hash of the critical binary changes unexpectedly between patch cycle. And number 5, software bill of material, the SBOM plus CVE correlation. So when a new supply chain vulnerability is announced, we can query our SIEM for affected software instances. So a proactive threat hunting. So a proactive threat. So a proactive threat hunting is going to play a crucial role here. And the pro tip is post solar wind supply chain detection is a board level concern now. So showing you have thought about it, monitoring trusted software's network behavior is a very current and impressive answer. All right, 75. How would you detect unauthorized cloud resource creation, the crypto mining, and shadow IT? So, cloud resource creation and deletion via CloudTrail, AWS, or Azure activity logs, we can detect these kind of activities. So, here are few points or few signals that we need to monitor. Number one, new EC2 or VM instance in unusual region or of the GPU types like P3, G4, or crypto mining. So these are common for crypto mining. Number two, new IAM user or access key created outside the provisioning workflow. So this is another sign. Number three, unusual API call from personal developer account in prod accounts. Then number four, cost anomaly correlation. So integrate AWS cost anomaly detection finding into SIEM. And number five, new resource tagged personal or untagged. So this is a violation tagging policy. So if you are tagging your resources with a special name or your tagging policy name, and if something is tagged as personal or untagged, then it is a violation. So the rule, we can create any EC2 creation in region your company doesn't operate in equal to immediate alert. Pro tip is crypto mining is one of the most common cloud compromise outcome. So attacker love your GPU instance because they are going to get it for free, right? So unusual reason plus GPU instance type is a near zero false positive rule that easy to write and high value. 76, compare Splunk, Microsoft Sentinel, and Elastic Seam. So when would you choose each? So number one is Splunk. So Splunk is most mature because this is very old and boss of Seam, and this is most powerful search, like using SPL. So that's uh, Splunk processing language, the SPL. They use SPL query to search the data, create the dashboard, create query, report, etc. And so it is industry standard for large enterprises. But the drawback is it is very expensive and best when you need deep custom analytic and have the budget. So budget is the factor in Splunk. And then Microsoft Sentinel. So it's a cloud native. So everything is on cloud. Like if you have Azure cloud, you can create Sentinel within 15 minutes. And also the deep 365 and Azure integration. So they have native integration for Azure services and Microsoft services, and it is KQL based. So the query language they use for searching, creating dashboard, or uh, threat hunting, the Custo query language. So they have consumption pricing. So you can pay as you go. So this can be cheaper because if you consume 100 GB data ingestion, you need to pay only for 100 GB. So this is for best Microsoft heavy environment. And also they are not only SIEM, they have been built uh, pay as you go model for SOAR as well. So Sentinel is not only SIEM, they are SIEM plus SOAR. Then the Elastic SIEM. So Elastic SIEM is open source and very friendly SIEM, and they are using the EQL query language, which is very powerful, and self-hosted option is available in Elastic SIEM to control the cost and growing detection rule community. So they have a very rich community, and you can copy and create use cases from there directly. So this is best for cloud native or cost sensitive environment with a strong engineering team. So in 2025 and 2026 context, Sentinel is growing very fast, while the Splunk is acquired by Cisco, so they are now more stronger, and Elastic is gaining ground in mid market. So the pro tip is you will almost always be asked about at least one of these in depth. So you can focus on one, either Sentinel, QRadar, Splunk, or Elastic. So pick one and go very deep. Know the query language, architecture, the pricing model, and the uh, storage model. Then the broad familiarity with one deep expertise when in the interviews. 77. What is KQL, the Kusto query language, and how it is used in Microsoft Sentinel? So, Kusto query language is the query language used in Microsoft Sentinel, Defender, Azure Monitor. So, basically, this is used in Microsoft Security Stack. And the example query to detect failed login is we can start with sign in log. So, this is a table. This is a data table where all the sign in log related data is stored. So this is similar to the indexer in Splunk. And then we can use a pipe to narrow down the result, then filter where the result type is not equal to 0, and then another pipe. So summarize failed attempt equal to count by user principal name and then IP address. So where the failed login attempt greater than 10. So if the event is 9, 10, or 8, it is not going to trigger. But when the failed login attempt is increased 10, it is going to fire an alert. So the key KQL operators are where. So this is going to provide the filtering part. So here you can see where result type is not equal to, and then summarize part is going to aggregate the data, aggregate the result. So it is going to aggregate the failed attempt count, and then project, which is going to select the field. So if you want some specific result in columns, you can utilize it using project. Then the join, so join is used for combining data. So suppose you have sign in logs and you want to join it with VPN logs, you can use the join. So this is how the correlation rule works in Sentinel. Then extend, so this is for add the calculated fields. Then parsing part for extracting data from strings. So KQL is beginner friendly but has advanced features like time series, machine learning plugins. So machine learning plugin like this series decompose anomalies, and then also you can call the external data. So why it is beginner friendly? Because you can start with very simple keyword like search, and then put your keyword here, and it will give you the result. So pro tip is, if interviewing for Sentinel role, be ready to write a KQL query on the spot, and practice of the top 10 detection queries: brute force, impossible travel, process creation, anomaly detection. KQL documents are very excellent and free. So guys, if you need a KQL learning series, let me know. I can create a detailed video or detailed playlist for KQL learning. You can just drop your question in the comment. 78. What is SPL, Splunk Processing Language, and what are some key commands? So SPL is Splunk search language, and it is pipeline based. So you can search the data, you can transform the data, also you can report the data. So the key commands are search for filtering. So you can start with search, and then you can put your keyword. It is that easy. And then state count by field. So this is going to aggregate the data and narrow down the result. Then eval command, so this is going to calculate the fields, and the rex is for regex extractions, and the lookup is for enriching the lookup table. So suppose uh, you can create the CSV of threat indicators, and then you can use the lookup to call the CSV data in your query. then the join command for combining multiple data sets, and the transactions for grouping related event into multiple sessions, and the T state is ultra fast states on the indexed field, and make result plus evaluation. So this is going to test data generation. So for example, we can write a simple query here. We can start with the index windows. So index windows is basically where the windows data is saved. Windows data is saved, and then event code 4625, which is for the failed login, and this is Windows event, and then state count by source IP. So this is going to provide all the source IPs with the numbers of events, and then where count is greater than 10, this is going to detect it or create a report for it. So if you want, just type in the comment section. I will create a detailed video for SPL learning with hands-on. Just let me know in the comment box if you want. The pro tip is T state is the performance secret in Splunk. So this query is indexed field without reading new events, and it is 10 to 100x faster for the queries. So knowing T state shows you think about production performance, not just correctness. 79. What is IBM QRadar and how does it architecture differ from Splunk? So basically, the QRadar is IBM's SIEM. Historically, it's dominant in financial services and government, but now they are supporting security side as well. So in the architecture, they have event processor for ingesting the data and the normalizing the data. Then they have flow processor for network flow analysis. So this is the QRadar's differentiator, and then event collector. So they have the event collector. So event collector is basically used for remote collections, and then console. So this is a very simple architecture. So console is for management plus analytics. So the key differentiators are they have the built-in NetFlow IP fix analysis is native. So this is the main differentiator in QRadar, and QRadar can correlate security event with network flow natively. So they don't need extra engine or some external component for that. And the query language they support is AQL, the Arial query language. So you can write the Arial query language to search the data and create report or dashboard. And the use case detection via rules and building blocks. So this is the thing that make it different from others. So if you don't know writing the AQL or any query language, you can use the telemetry or blocks to uh, create your use case. And the offense management like incidents is built in. So the incidents called here as offense management. So QRadar is generally more appliance oriented and harder to scale than cloud native options. And the pro tip is QRadar is still widely deployed in regulated industries. So if job specification mention it in the interview, definitely it is going to very deep, and you need to explain the offensive rules, building blocks, AQL at minimum, but know the architecture as well. This will help you to crack the interview. What is Google Chronicle and what makes it different from traditional SIEM? So, Google Chronicle, now known as SecOps, the Google SecOps is a cloud native SIEM built on Google's infrastructure. So, like Sentinel built on Azure, Chronicle is built on Google's cloud. So the key differentiators are they have fixed price and unlimited data models, no per GB license. This is huge, right? And this is game changing versus Splunk or Sentinel. Then number two, the petabyte scale natively, so you can expand your data to petabytes, not just TBs. And then they have Yara L detection rules. So it's a Google's detection rule language and different for SPL, different from SPL and KQL. So they use Yara L, and this is similar to the Yara rule. and then built-in threat intel from Google's threat intels like virus total, mandiant post acquisitions, and then retro hunting. So you can run new detection rule against years of historical data instantly. And the target markets are large enterprises, MSSPs that generate massive log volume because they have no licensing for data. And the pro tip is Chronicle's pricing model is its biggest disruptor. So when a Splunk customer get a 500% cost increase renewal, Chronicle is flat rate pricing is very compelling. So know this angle for enterprise scale oriented interviews. And also they have built the Gemini with Google SecOps. So now you can get a summary of the alert, URL, and some other correlations of the data and report. So this is AI SIEM, I would say. 81. What is Elastic SIEM? Elastic Security, and how does it compare? So Elastic Security is a SIEM built on Elastic Stack like Elasticsearch, Kibana, and the strength are this is open source. So this is the biggest strength. It's open source, free to self-host, and the easiest normalizations, powerful EQL query, the event query language. So they use event query language, and this is very excellent endpoint integration via Elastic Agent. So you can deploy Elastic Agent on multiple endpoints, and they have a strong community rule. So you can just copy and create your detection logics, and the detection rules in AQL looks like this. So sequence by host dot name, and then the process where the process name equal to command line exe, and then another logic network where the destination port equal to 443. So this is how with plain language you can write the EQL detection rules. So Elastic is great for cost conscious organization, and then cloud native environments, and the teams with a strong engineering. So if you have a strong engineering team, cloud native environment, and you have no cost, you can deploy the Elastic SIEM. And the weakness are like it's weaker than Splunk for enterprise features, support, and then compliance reporting. But the Kibana dashboard are highly customizable. So this is another advantage they have. So they have Kibana dashboards. So the pro tip is Elastic EQL, the event query language with sequence detection is extremely powerful for catching multi-stage attacks. So this is the differentiator. And if you have used EQL sequences to detect process, then network pattern, you can mention it. That's a differentiator. 82. What is a MISP and how it is integrated with a SIEM? So MISP, malware information sharing platform, is an open source threat intel platform for sharing, storing, and correlating IOCs. So it is a platform, the IOCs platform, which can store the IOCs, correlate the IOCs, and then share the IOCs. And the best part is it is open source. Open source. So you can integrate it with your SIEM. So suppose you have a Splunk, so you can integrate this with your SIEM using uh, STIX taxi protocols. So number one, export IOC speed from MISP, and then SIEM lookup table like IP block list, malicious domain list, file has list. So you can ingest the IOCs from MISP database and then correlate with your SIEM. Number two, STIX taxi endpoints, so SIEM pull structured threat intel directly from MISP using STIX and taxi protocols, and then event correlation. So when SIEM event matches a MISP IOC, and alert is enriched with MISP event context like threat actor, campaign, related IOCs, etc. And this is bi-directional. So when SIEM detect a new IOCs in an incident, you can post it back to the MISP to share it with community and partners. So that's how it is like working, and it is open source and community based, community intel based. So MISP is heavily used in ISAC and government critical infrastructures environment. So knowing it as a strong signal for a public sector or critical infrastructure SOC role. So what is Cribble Stream and why has it become popular in SIEM architecture? So Cribble Stream is a vendor agnostic log routing and transformation platform, or we can say it's a observability pipeline. So think of it as a smart intermediary between log source and a SIEM. So if you know, earlier we were using Syslog servers. This is your log and this is Syslog, and then you are going to forward it to SIEM. So basically, instead of Syslog, you can use Cribble here. So Cribble is a data pipeline and observability tool, and the key capabilities are the routing part. So you can route your log to multiple destinations like SIEM, S3 bucket, or another SIEM. So if you're using Cribble and sending log to Cribble, you can send it to multiple destinations like SIEM 1, SIEM 2, S3 bucket, or blob storage. Then the filtering part, so high volume noise before it hit the expensive SIEM storage. So you can filter the junks here or remove the non-security data, or the data you require you can only transfer those. And then the transformation, so it also normalize and uh, reduce the junks, and then it normalize the log with different formats and the mask sensitive field like PII data. Then it is going to enrich it and then replay. So it is going to re-ingest archive data for new detection rule or investigation. So this is a cost driver, and by filtering noise before SIEM like your Splunk or Sentinel ingestion, Cribble can reduce SIEM license cost by 30 to 60%. But the important part is like buying Cribble license also you need to spend some money, but it is not that expensive. So you can save your licensing, the expensive SIEM licensing cost from 30 to 60%. So this is Cribble, and this is your multiple log sources. You can transfer the log to Cribble, and then Cribble is going to route the data. Cribble is going to filter the data, transform the data, and also replay with the data. Replay with the data. So the pro tip is Cribble is one of the hottest tool in enterprise security operations right now. So knowing it well is a genuine job market differentiator. So especially for senior SIEM and detection engineering roles. So if you know Cribble administration, then you are definitely going to rock the interview. What is Zeek, formerly Bro, and how does it complement a SIEM? So, Zeek is a powerful open source network security monitoring framework. Unlike the raw PCAP capture, Zeek extract and logs network protocols, metadata like DNS queries like DNS.log, HTTP request like HTTP.log, TLS certificate like SSL.log, the connection record, con.log, file transfer, SMTP. So Geek logs feed into SIEM to provide rich network layer visibility that most network device don't provide. So Geek is very Geek is very powerful network traffic capturing tool, and then you can transfer it to SIEM. So the use case in SIEM you can create like DNS tunneling detection, TLS certificate anomalies, beaconing detection, exfiltration, volume tracking, protocol anomaly, and also this is a great tool. And if you're not using it, then you're missing a lot of your network traffic with context. So the pro tip is G plus Surikata, the IDS rules, is a classic open source network security management stack, and also the security onion package both with Elasticsearch and Kibana for free tier SIEM. So knowing this stack is great for SOC roles at the smaller organizations. All right. So, what is the Hive and how does it integrate with the SIEM SOC workflow? So, the Hive is an open source scalable security incident response platform, the SIRP. So, that means essentially a case management tool for security incidents. So, the Hive is a case management tool for incident response. And the SIEM integration, so SIEM fire an alert, then SOAR or workbook automatically create the hype case with alert detail, and analyst work on the case in hype and add the observables, IOCs, assign tasks like triaging, containment, eradication, and all, and then document findings. So the hype integrate with Cortex like automated analyzer like virus total lookup, IP reputation, sandbox detections, and the MISP IOC sharing. So these kind of regular tasks you can complete in Hive by integrating it with SOAR. So the combo, the Hive plus Cortex plus MISP, is a powerful open source SOC stack. So the pro tip is if you are in a budget constrained SOC, knowing the open source SOC stack like Elastic SIEM, Hive, Cortex, MISP, Shuffle 989 for SOAR is valuable. So it is increasingly used by MSSPs and smaller organizations. 86. What is detection engineering? How does it differ from traditional SIEM administration? So let's understand the SIEM administration. So SIEM administrator keep the platform running. They do all the maintenance part. They work on all the health related issues on SIEM, and also onboard log source, manage infrastructure, ensure availability. It is very reactive role and operations focused role, because if the availability is down, then your whole SOC team will be idle, right? So you cannot detect the threat, you cannot uh, respond on the attack. While the detection engineering is like proactively build, test, and maintain high fidelity detections. So the detection engineering part focus on threat hunting, detection use cases, report generation, tuning part. So they treat detection as code. So sometimes they use Gate, CI/CD pipeline, and they do all the testing frameworks, and then map the rule with threat intels, measure the coverage, and continuously improve by adding some more logic, fine tuning the rule and all. So detection engineers bridge threat intel, purple team findings, and the SIEM they translate attackers TTP into working tested productions rules. So basically they focus on the rules, detections, logic, fine tuning. So it's a software engineering discipline applied to security, we would say. So the pro tip is detection engineering is one of the hottest career track in security operations. So if you want to pivot from SOC analyst to detection engineer, build a GitHub with Sigma rules, Yara rules, and attack coverage map and detection testing write-ups. 87. What is risk based alerting, the RBA, and how would you implement it in Splunk? So risk based alerting assign risk score to entities. So this is automatically going to assign some numbers to your entities like user and host, like 10, 20, 99, based on the behaviors. Then alert when cumulative risk exceed to a threshold. So suppose you have a threshold greater than 50 risk score is going to trigger an alert. So this is going to alert for that. So this is rather than alerting on every individual event, you will get alert on the risk based numbers. So how you can implement it? So number one, the risk event. So each detection rule assign a risk score to an entity like brute force from host X equal to plus 30 risk to a host X, and then risk index. So Splunk have risk index aggregator for these score per entity. over a time window. So suppose you have a detection rule and you can set risk score for host 30 30 number, and then for the IP you can set 40 number, and the user you can set 50 number. So this is a risk score, and this is automatically going to assign to evolve entities, and then this score is going to send to a database in Splunk, and if any uh, rule trigger, it is going to assign the number. So if the threshold is increased, it is going to trigger an alert. So number three, incident rule. So alert when the user risk score exceed 100 in 24 hours. And the result you will find, you don't alert on one failed login, but after 10 suspicious behavior in a day, the entity's cumulative risk trigger a high fidelity, high context alert. So dramatically, this is going to reduce the alert volume while increasing the quality of the alert. So the pro tip is Splunk's enterprise security risk framework implements RBA out of box. So knowing this shows you at an Splunk ES level of maturity, which is expected for senior SOC and detection engineering role. All right, 88. How do you approach detection as code in a modern SOC? So detection as a code treats detection rule the same as software. So this is a software term. So this is going to version the detection rule, then tested, reviewed, deployed via CI/CD pipeline. So CI/CD pipeline looks like this: uh, versioned, and then tested, then reviewed, and then deployed. So the main components are: number one, the rule authoring in Sigma. So Sigma is vendor neutral YML format that you can reuse everywhere. So like in all SIEM, you can utilize it. Then the version control in Git. So if the rule changes, it is going to be tracked with versions. Then peer review with PR or via PR. Then testing pipeline. So you can do the unit testing with synthetic log data. So using tool like Atomic Red Team, Detection Lab, etc. for testing purpose. And then CI/CD. So on merge to main, automatically compile the Sigma rule, then targeting SIEM query language, validate syntax, deployment to staging, and then the production deployment. So after passing staging test, you can deploy the rule directly to the production environment. So the benefits are the auditability. So whatever you are creating, you have the auditability, and then rollback capability. So if you want to roll back the detection rule, you can roll back it using CI/CD pipeline. The collaboration is also can be done, and the consistency across multiple SIEMs. So you can build one rule and deploy it everywhere. So basically, if you are a MSSP vendor or managed security service provider, this will be very helpful for you. And then pro tips: Sigma plus GitHub Actions plus Pi Sigma is a practical starting point. So building a public detection repo in GitHub, then even a small one. So if you have like 5 to 10 rule in your GitHub repository, that's impressive and proof of this skill in interview. 89. What is MITRE attack and how do you use it to drive detection strategy? So MITRE attack is a generally accessible knowledge base of the adversary tactic, technique, and procedure, the TTPs, KB of TTPs, and this is based on the real world observations. And the structures are, you will see a tactic. So the tactic like 14 categories like initial access, executions, persistence, privilege escalations, defense, evasions, credential access, discovery, lateral movement, collections, C2, exfiltration, and the last one is impact. So this is the tactics that they follow. And then we have a technique. So techniques have 100 of the specific method, like each with detection and mitigation guidance. And using attack, you can map your detection rule to the technique and visualize the coverage in navigator, and then identify the gaps. And also you can prioritize by threat intel, by technique or relevant apts using against your industry. And also you can build the rules to filling the gap. So basically, uh, MITRE heat map or MITRE dashboard in your environment can show you how much covered in your environment from the detection point of view, and what are the opportunities to fill the gap. And the pro tip is attack is a shared language of modern detection. So every detection conversation in a senior level interview will reference it. So you can download a navigator, play with it, and then build your own coverage map, even for hypothetical environment. 90. How would you measure and report on SOC effectiveness using SIEM data? So the key SOC matrix in your SIEM you can create. So the detection coverage, so how much percentage of the attack technique with active detections. So this will show you the coverage in your environment. And then MTTD, so this is a mean time to detect. So this is going to show when did the attack start versus when did the alert fire. Then MTTR, so mean time to respond. So suppose the alert creation is complete, and how much time your SOC is taking to closing the case. Then the true positive false positive ratio per rule. So this is another good matrix you can create. And alert volume trend, so are we drowning or optimizing. And then analyst throughput, so alert closed per analyst per day. So if any analyst is closing alerts within 1 minute, so that's a red flag. And dwell time, so rules with no alert in 90 days. So this is a deed weight, and you need to review the rules, and then if required you can change the logic or tune the rule. Then report weekly to SOC management, and monthly to CISO, and quarterly to the board. So the executive format, you can create the risk posture, trend, key incidents, and then investment needed for your SOC. So these are the key metrics you can cover in your SOC environment. And the pro tip is being able to define SOC KPIs and explain how would you track them in SIEM dashboard is a leadership and managerial level skill. Even a junior candidate who can articulate metrics stand out. It shows you think about outcome, not just completing your regular task. 91. What is a purple team exercise and how does it improve seam detection? So, a purple team exercise is red team attack plus blue team detects. So, it's a combination of both the teams and reviewing gaps in real time. So, the process we can follow for purple teaming is number one, planning. So, we can agree on the attack techniques that we are going to test. Then red teaming exercise where the red executes. So red teaming is going to execute some specific attack technique on agreed systems using atomic red team, cobalt strike, and some manual patterns. And then number three, blue monitors. So blue team can monitor were alerts generated for the red teaming activity, were they investigated correctly or not. Then number four, gap analysis. So if you identify techniques with no detection or poor detection or slow detection, so you can improve it. Then remediation part, so we can create new rule, new log source integration, and then tuning part. Then retest. So once you complete the remediation part, then you can retest. So purple team exercise drive the most reliable detection improvement because they test your real environment, not lab condition, right? Or not the out of box rules. The pro tip is you can run purple team exercise with atomic red canary. So they have atomics for MITRE technique and you can test it. So it's a free open source and attack mapped test cases even without a red team. So the solo detection validation with art is underrated and impressive to mention in the interview. 92. What is a SOAR playbook and how do you design one for phishing response? So a SOAR playbook is an automated response workflow triggered by SIEM alert, and the phishing response playbook can contain number one, the trigger. So if the defender for Office 365 or any other phishing security solution detect alert, that enter in SIEM, then SOAR start firing. Then auto actions like extracting email metadata, who is the sender, what is the subject, is there any attachment or URLs. Then number two, submit attachment hash to virus total, URL to URL scan, and the IP is to IP void. And then check sender domain age, whether it's a newborn domain. So if it is a newborn, then it is a high risk. And then pull all recipients from mail server logs. Number five, auto quarantine the email from all the mailbox if the virus total score is greater than threshold that you defined. And then human decision point. So analyst reviews, enrichment, decide to block the sender domain or not. So if confirmed, you can block the domain in email gateway, add the SIEM watch list, and notify recipients and create awareness ticket. So suppose this is your SIEM, and SIEM have Office 365 data, and also SOAR is integrated with SIEM. So this is going to do the auto actions here. So it is going to pull all the subject, sender, attachment, and URLs, and then submit these entities to sandbox, and then check the domain age, and then pull the recipient detail, and then quarantine, and then close. So the pro tip is design playbook with explicit human approval steps for high impact actions like blocking production systems, disabling user account. So the automation should handle the enrichment part, and humans should approve the consequences. 93. What is an MSSP and how does C management differ in an MSSP context? So an MSSP, the managed security service provider, they are the service provider for your security and going to provide security monitoring as a service to multiple clients. And SIEM in MSSP context differ, little bit differ, like multi-tenancy. So they follow the multi-tenancy model where a single SIEM platform managing 50 to 500 clients and each isolated in their own data space. So suppose this is an MSSP, they have a SOC center where they are going to monitor 24 bar 7 SOC services, and they have multiple clients across the various geolocations. So suppose somebody have SIEM, some have XDR, some have network security, some have some MDR or something. So they are going to monitor everything at one place. And the scalability, so need to handle massive aggregate EPS across multiple clients, and then standardized use cases. So they cannot build a custom rule for every client and need a standard detection library with client specific customization layer. So they have a pipeline and a library where they store all type of use cases related to various clients. Suppose if you are in a health environment, then they have use cases for health. If you are in energy sector, so they have a specific use case for energy sector, or some defense sector, or some IT software sector. Then SOC efficiency, so if you need SOAR automation for repetitive tasks across clients, and uh, SLA management. So they have a very good SLA like MTTR SLA per client, and it is easy like critical alert acknowledge in 15 minutes. And platform popular for MSSPs are Splunk, yes, with tenant isolation, Microsoft Sentinel, Curadar, Devo, Securonyx, etc. And the pro tip is MSSP SIEM roles are great for breadth. So you will see 100 different environment, and if you want depth, go in house. So mention this trade of if asked why you are interested in MSSP versus enterprises role. So this is a big differentiator here. 94. What are some common SIEM bypass technique attackers use, and how do you counter them? So this is very important question. So the common SIEM bypass techniques are log flooding. So attackers generate millions of events to bury the malicious ones. So how you can counter? So you can do the rate limiting, anomaly detection on log volume size. So you can create alert on your log spike and tackle it. And then time stomping. So attacker can modify event time stamp to move out of query window. And the counter is rely on the index time, not on the event time for critical correlations. Then log deletions. So attacker may also clear event log like event code 1102, and the counter is forward logs in real time to immutable SIEM and detect 1102. Living off the land, so use built-in to avoid custom malware signatures. The counter is behavioral detection. Parent child rules will help you to identify their behavior. Slow and low, so they can operate below threshold trigger. And the counter is you can use the UEBA, longer time window correlations, and behavioral baseline. And number six, encrypted C2. So you can they can hide C2 in legitimate services. And the counter is J3 traffic analytics and the beaconing detection. So this is very important question. And the pro tip is attacker literally study public SIEM detection logic to evade it. So the best counter is behavioral anomaly detection that does not have a known signature to evade. 95. How does SIEM integrate with zero trust architecture? So zero trust always assume breaches and they never trust and always verify. So the SIEM is the continuous verification and monitoring backbone. And here are a few points that we can cover to integrate it with zero trust architecture. Number one, identity monitoring. So this is a main pillar of zero trust. So you can log the identity related logs and analyze every authentication events across in your environment and access request. And when the SIEM detect anomalies in never trust, always verify access patterns. Number two, device posture monitoring. So like your MDM EDR signal in SIEM track device compliance. So if a device fails posture correlated with access event. Then micro segmentation monitoring. So SIEM track east west traffic for policy violation, and then just in time access. So SIEM also monitor the time limited privilege elevations and alert if they are abused. And then continuous risk scoring. So UEBA scores entities continuously. So the zero trust policies engine can consume SIEM risk score to dynamically restrict access. And the pro tip is, so zero trust plus SIEM is a board and CISO level topic in 2025 and 2026, and being able to articulate how SIEM provide the continuous monitoring layer for GTA shows strategic thinking beyond day-to-day SOC work. 96. How would you build a threat hunting program and integrate finding into SIEM? So the program structure looks like this. Number one, intelligence driven hypothesis. So based on the threat intel reports, CTI reports, recent incidents, uh, like we believe APT29 may be targeting us, so we can add their signatures TTPs into X system. And then data availability checks. So do we have all the required log sources to hunt for this, to hunt the APT29? Then number three, hunt executions. So you can do the query in your SIEM log, EDR log, network log for indicators and document the findings. Number four, if something found, so if something is found, then you can execute the full incident response. Then number five, always write a detection rule. So future occurrence alert automatically. So if you find something, then always write a rule for it. So this will save your time for next detections and next hunting. And then close the loop. So if nothing is found, document that the hunt was performed. So this will give some compliance value and update coverage map. And the cadence is here. So threat intel driven hunt weekly, technique coverage hunt monthly. So this is the cadence. And pro tip, the best hunters have a hypothesis plus query plus rule model mindset. And every hunt should either find something and trigger incident response or result in a new rule that make the next hunt unnecessarily. 97. What is the role of machine learning in modern SIEM platform? So in modern SIEM platform, the machine learning role is number one, anomaly detection. So this is going to baseline the normal behavior for user, host, applications, and flag the statistical deviations for that. And then entity risk scoring. So continuously score entities based on the behavioral signal. And then alert clustering, so group related alert into incident automatically, so this is going to reduce the cognitive load. And then DGA detections, so machine learning classifiers identify algorithmically generated domain name. And then peer group analysis for comparing user behavior to their peer group, so it's a financial analyst suddenly behaving like a sysadmin is an anomaly. So NLP for log parsing, so machine learning assisted parsers generation for new log formats. But the limitations are like machine learning need time to baseline, because this have some learning period like 30 days, 60 days, or 90 days. This is also going to produce some false positive or new unusual environments, is a black box, and it is hard to explain why it is fired. And the pro tip is machine learning in SIEM is augmented, not replacement. So the best answer positions machine learning as handling the unknown gap, while rule handle the known bad. So interviewer love this framing. 98. How do you approach SIEM for OT and ICS environments? So this is another very good question. And OT and ICS SIEM is little different. So the safety over security. So you cannot patch or restart a blast furnace like you would a Windows server. So OT system is not equal to IT systems, right? So their availability is top priority. So the log sources are different. So OT systems have different protocols like Modbus, DNP3, and some framework like 61850 protocols, historian servers, PLCs, HMIs, SCADA, and the detection focus. So detection focus is based on unauthorizing engineering workstation connections, ladder logic change, unusual control commands, ICS specific malware like Triton or Indus Destroyer, and purpose built solutions. So the Clarity, Dragos, Najomi, Cybervision for ICS specific detection, and they can directly feed to SIEM. And the architecture is like passive network monitoring for tap, not agent. And touching OT system is very dangerous. So you can normalize the OT event and then uh, do the SIEM correlation with IT events. So IT OT boundary crossing is high signal. And the pro tip is OT and ICS security is a highly specialized and well paid niche. So, if you are targeting critical infrastructure role, deep knowledge of Purdue model, NERC, CIP, and ICS specific detection like Dragos and Clarity or Cyber Vision is a highly differentiating in this role. Question 99. What is a security data lake and how does it differ from a traditional SIEM? So a security data lake, separate storage for analytic. So you can dump all the security data, logs, telemetry, network capture into a keep object stored like S3 bucket, ADLS, then run analytic engine on top as needed. So suppose this is a security data lake, and since the traditional SIEMs are very expensive to store your data for a long time, you can dump all your security data here for longer retention, long retention data. So the difference from SIEM, number one, cost. So the storage at 0.02 per GB versus SIEM as $2 for 50 GB. And the flexibility, so you can query with Spark, Athena, Databricks, or any SIEM. No schema on write, so you can store the raw data and then whenever needed you can parse it. But the limitations are like query latency, so it takes minutes versus second, and less real time alerting, and also require data engineering expertise to ingesting the data and playing with the data. So the modern trend is like SIEM for real time detection plus data lake for real term retention and hunting. So the platforms are like AWS Security Lake, the OS SF based, Snowflake, Microsoft Sentinel data lake model, etc. And the pro tip is security data lake is a fast growing architectural trend, especially for large organizations drawing in SIEM cost. So AWS Security Lake announced in 2022 especially target this use case with OCSF normalization. All right, the final question we have, where is SIEM heading in next 3 to 5 years and what skill should you develop now? So the trends are like cloud native SIEM dominate. So like SIEM, Sentinel, Chronicle, Elastic Cloud, or Splunk Cloud is going to dominate, while the on-prem is going to shrink in 3 to 5 years. Then XDR convergence. So SIEM and XDR feature is going to merge. So if you see M365 Defender has already merged and created a unified security platform right now. So this platform do both detection and response. And then AI assisted detections like a lot of the LLMs going to help write detection rules, triage alerts, and then summarize incidents. So especially the Microsoft Copilot for security, Google Gemini and SecOps, and then security data lakes. So this is going to help in cost driven decoupling of the storage and analytic. And number 5, detection as code mainstream. So detection as code going to help write the query in Sigma, Git, and using CI/CD for all detections. Then OCSF adoption. So open schema standardization reduce parsing overhead. So the skill you can develop now, KQL for Sentinel growing fast, and then Python for automation, machine learning, pipeline scripting, and the detection engineering like Sigma and MITRE attack, and the cloud security stack like CloudTrail, Intra ID, GCP log. So these are the important stack if you are looking your career as a detection engineer or SIEM engineer. And the pro tip is the biggest career differentiator right now: detection engineering plus cloud expertise plus ability to code. So the pure play SIEM admin roles are shrinking right now. But if you know the building engineering skill, contribute to open source detection repos, and get cloud security certifications, then it will be a win-win situation for you. So I hope you like this series, and if you like, hit the like button, subscribe, and comment if you have any questions, or if you like the video. So share your feedback. All right, Infosec Pandey here, and I'm signing off for today.